Hi, seventh graders. Here's another lesson on probability. This is another fun way to do it that's more visual than the fractions that we were doing last week. I really enjoyed this way. It's called tree diagrams. Diagrams are a nice way to visually show all the possibilities. Here's a quick way that it might look when we're all done. We're going to label all these different ones, and these are different events. Like this is something that is going to happen. Here are the first choices, here are the second choices, and those choices are called stages. So let's take a look at one here. A sandwich can be made out of 2 types of bread, rye or white, 3 types of cheese, cheddar, Swiss, or provolone, and 4 types of meat, turkey, salami, bologna, or ham. Okay, so we're starting with a dot up here at the top. And first we have 2 types of bread. So I'm going to do 2 branches. And I'm going to spread them out pretty far here because I know ultimately I'm going to be trying to get a lot of things in between here. Now you could write the whole thing, but I usually just do the first letter, especially when they're different. So here's our rye bread over on the left. Here's our white bread over here on the right. Next we have 3 types of cheese. Now, I don't know which type of bread you pick, so I'm going to have to do 3 types of cheese off of each of these. So I'm going to have 1, 2, 3, 1, 2, 3. Again, a good reason why you want to spread them out. So I'm going to label them. If I had rye bread, I could have cheddar, Swiss, or provolone. If I had white bread, I could also have cheddar, Swiss, and provolone. And then I'm going to have 4 types of meat. I'll try to do the best I can here with my fingers. So we need 4 off of each of these because I don't know what bread you want and I don't know what cheese you chose. So each of these is going to get 4 branches. And we would label these. So I've got turkey, salami, bologna, and ham. Turkey, salami, bologna, and ham. Doing them for each of these. Now, if you had the same first letter, you could come up with something else that you want to label them, maybe 2 letters, but this one's nicely written that they're all different. So how many possibilities are there here? I'm going to count along the bottom. Let's go highlighter. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've got 24 different possibilities there on the bottom. So if I'm doing a probability, it's going to be out of 24 different sandwiches that I could make. So every one of these fractions is going to have a 24 on the bottom. Now, when we pick a sandwich, we're going to follow a path down. So for example, I'm going to pick rye bread, Swiss cheese, and ham, and that is 1 sandwich. Another one might be white bread, Swiss cheese, and ham. That's a completely different sandwich, and so on. So what they might ask is they might say, how many of these sandwiches have provolone and salami? So I would come down this way, provolone and salami. There's also one over here, provolone and salami. So there are 2 sandwiches out of these 24 that are provolone and salami. Just a very nice visual way to see all the different combinations that are possible. If you remember that P in front of the parentheses means what is the probability of, in this case, a family with 3 children having 1 boy. So what are our branches going to be? They're going to be the children. So I'm going to start with the dot at the top. And what's the chance if you have a child? 2 chances. It's going to be a boy or a girl. And that first stage is the first child. Now I want 3 children, so the next one also could be a boy or a girl. And this will be our second stage. And then for our third child, it could be a boy or a girl. And labeling that for each of them. When I'm all done, I can count on the bottom and see how many different ways this can be done. So that is 1, 2, 3, 4, 5, 6, 7, 8 different ways that you could have 3 children. Okay, the question is asking, what is the probability of having just 1 boy? So if I went this way, that's my 1 boy, so I couldn't go to the left, I'd have to go to the girl. And then if I only want 1 boy, Okay, so that's one branch with one boy and two girls. Over here, here's a girl, there's a boy. So I've already got the boy, so I have to go that way. And I could go this way, girl, girl, boy. So there are three ways I could have one boy in this family. I don't know if it's the first child, if it is the second child, or if it is the third child. So there are three different ways that you could have one boy out of these. Okay, our next one is asking, what is the probability that a family with three children will have two boys? So I'm going to follow all the paths that have two boys. So if I come to this boy, I need another boy, and there's a girl, so that's boy, boy, girl, that works. Boy, girl, boy, that's two boys. Neither of those other two work. Coming this way, girl, boy, boy. And now I can't do the next one, and I can't do the next one, so that is three. So there are three ways to have two boys in this family. So it is also 3 out of 8. Okay, what's the chance that all three children will be three boys? So I'm going to follow down this way. Here's boy, boy, boy. That is the only line in this whole thing that's going to have three boys. So there is 1 out of the 8. So you have a 1/8 chance of having all boys. You have a 3/8 chance, equally likely to have one boy versus two boys. Okay, in our next example, what's the probability of flipping heads and rolling a 5? So I have two events, so I'm going to have two stages. So I'm going to start with my dot at the top, and I'm going to have the branches for flipping a coin, heads or tails. So that is 2, that is heads or tails. And then I'm rolling a die, so that's 6 possibilities because the die has 6 sides. So let's get 1, 2, 3, 4, 5, 6. And then the same on the next 1, 2, 3, 4, 5, 6. And I can label those the 6 sides of the die, and I'm going to label them for both of them. So how many possibilities do we have altogether? If I add up on the bottom, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 different ways that I can flip a coin and roll a die. The first one's asking what's the chance of flipping heads and rolling a 5. So I'm going to follow down the path for rolling head or flipping heads and then rolling a 5. There was only one way to do that, so that is a 1 out of 12 chance. The second one here is asking what is the probability of flipping tails, okay, and then rolling a number bigger than 4. So that could be both the 5 and the 6. So counting down here how many red paths I've made 2 red paths, so that is a 2 out of 12 possibility. Okay, our last one, we have this spinner with 4 sections. 2 sections are red, 2 sections are a lighter color. A spinner has 4 equally likely regions numbered 1 through 4, and it is spun twice. What's the probability that the spinner will land on a 1 on the first spin and on a red region on the second spin? So we're drawing a tree diagram to show those possibilities, starting with the dot at the top. I've got 4 sections, so I'm going to have 1, 2, 3, 4 branches, and those choices were the numbers 1 through 4. But on the second one, I'm looking for whether it's red or not, so I'm only going to have 2 branches, and that is red or I guess I'm going to call that yellow. Red, oops, red or yellow, red or yellow, red or yellow. So how many of these, what's the probability of spinning a 1 on the first and a red on the second? So I want to go to the 1 and then to the red. That is only 1 path out of how many paths? 1, 2, 3, 4, 5, 6, 7, 8. 1 path out of the 8. Okay, so along with this assignment, I posted a homework for you, so you can take a look at that. It's homework 5.4.